Question 4b. Now this is a simple harmonic motion question, so I'll read out the question for you. A particle is undergoing simple harmonic motion on the x-axis about the origin. It is initially at its extreme position, positive position. The amplitude of the motion is 18 and the particle returns to its initial position every 5 seconds. So the first part of the question asks us to write down an equation for the position of the particle at time t seconds. So as you can see, I've already drawn a diagram for you. So this is the information provided. See, it starts at its rest position at its highest amplitude of 18 in the positive region, and it oscillates back and forth every 5 seconds. So see, these two match up because that is a period. Okay, so the first part of the question asks us to find an equation. So the standard definition for simple harmonic motion is given by x equals a sine theta, or we can choose cos, so I'll choose cos for this convenience as you'll later understand, n t, where n is given by, where n has the relationship with the period such that t is equal to 2 pi n. So t is the notation for the period. Okay, so what we'll know now is we know that the amplitude, which is a, is given by 18. So straight away we can substitute a with 18. Now what we also know is that the period is 5 seconds because the period is defined by the time taken between two successive points in simple harmonic motion. So we can replace t with 5. Now we just need to make n the subject, which is rather easy. We just interchange those two values, so we get n is equal to 2 pi over 5. And now, if we bring it down here, we now have x is equal to 18 cos, now replacing n with 2 pi over 5, and we'll put t up the top, and that is the equation for part I. Now, you might be wondering why I chose cos. Well, if you notice here, if it was sine to start with, sine of 0 is equal to 0, so it would actually be here. But since cos of 0 is actually equal to 1, it begins at 18 as it's supposed to. So that's why I selected cos instead of sine. Okay, so the second part of the question asks us, how long does the particle take to move from a rest position to the point halfway between that rest position and the equilibrium position? Okay, so the equilibrium position is anywhere where the graph intersects the t-axis, so here, 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 and so forth, and its rest position is up the top of its peaks, where the tangent is equal to, tangent has a gradient of 0, okay? So what we're really finding is just how long it takes to reach here. So as we know, half of 18 is 9. So now really all we have to do is find, if x equals 9, we just have to find the value of t. Okay, so we'll let x equal to 9. So from part I, we know now that x is actually cos, 18 cos 2 pi over 5t. We'll divide both sides by 18, so we're going to get half equals cos 2 pi over 5t. Now for our general solution, now we can say that 2 pi over 5t is equal to pi on 6, pi on 3 plus or minus 2 pi k, where k is an element of the integers. Okay, so we need to choose the first time for convenience because we know it starts at 0. So we'll select the first time. So what value of k should we choose to make it the lowest positive number? Clearly, we'll choose k equals 0. So therefore, we get 2 pi over 5 times t is equal to pi on 3 plus 0. So clearly, it's just pi on 3. So now we divide both sides by 2 pi on 5. So we're going to get pi on 3 multiplied by 5 over 2 pi. Pi's cancel out. And what we're left with is 5 on 6. So the time it takes is just t equals 5 on 6 seconds.